What's up, math fans? I'm doing solving inequalities with fractional coefficients, all right? A couple of questions you might have is, what is the symbol? It means with. Fractional coefficients, well, you should have learned that a coefficient is a number in front of a variable. So I have my variable x, the coefficient is 2/3. That's what I mean by a fractional coefficient. I have my variable x, my coefficient is, there's no number here, you should know there's a 1, so the coefficient is 1/2. So fractional coefficients basically just means there's fractions throughout. And you might even see a fraction without a variable, and it's the same procedure. These questions you'll notice have all fractional coefficients, meaning the variable itself is not in the denominator, but it's even the same procedure when the variable is in the denominator. It just gets a different title. Those are just fractional equations where the variable could be anywhere. This is specifically where the variable is only on top, which makes it just this much easier, but it's still similar procedure. If you have any problems, if you're not understanding what I'm doing, then you might want to get more comfortable finding the least common multiple of numbers. And I do another video, so you can look for the one where it says solving equations, instead of inequality, solving equations with fractional coefficients. It's really the same procedure, just instead of a Pac-Man greater than, you'll see an equal sign. But the steps are all the same. The only thing different here is I'm going to do everything the same, and then I'm going to graph it also. I'm going to solve n graph, or plot on a number line. Okay, so step 1, if you saw that other video, is find the least common multiple of the denominators, also known as find the least common denominator. So what do I got? A 1, a 3, and a 2, right? Yes and no, be careful. This 1 is really 1 over 1. So now, a 1, a 3, and a 2, what is the least common denominator? What do all 1, 3, and 2 all go into? What do they all build up into? 6. How did I know that? Because it's easy for me to count by 3s, 3, 6, 9. Count by 2s, 2, 4, 6, 8. Oh yeah, they both go into 6, okay? Count by 1s, 1, 2, 3, 4, 5, 6. Everything goes into 6. So step 2 is multiply every single term, and there's 3 terms, all by that number 6. So 6 goes here, 6 goes here, 6 goes here. Notice you're multiplying by 6. 6 is a whole number, so it's really 6 over 1, okay? 6 is the top, the numerator. 6 over 1, 6 over 1, 6 over 1. I don't need to put it over 1 because I already know there's a 1 there. Why do I multiply by 6 everywhere? Because you're allowed to do that in equations and inequalities. As long as you do it to both sides, you're allowed to do whatever you want. So as long as you multiply every term by 6, you aren't changing the value of anything. Guess what else? The fact that I multiply by 6, well, here nothing cross cancels. Me here, I just got to multiply. 6 times 1 is 6, okay? But here, the fact that I multiply by 6, 3 goes into 6 twice, okay? That's what you want. That's the whole point here is, poof, I made the denominator disappear. No more denominator. 2 is on top, 2x is on top. 2 times 2x is 4x. And look at this, poof, 2 goes into 6. 3 times x is 3x. The greater than or equal to drops down. And now it's a basic, I want to say equation. It's an inequality, but it's very similar. It looks like I need to isolate x. So I'm going to subtract 4x on both sides. Cancel out, 6 drops down, greater than or equal to drops down, 3x minus 4x is negative 1x. And again, you shouldn't have to write the x, I'm doing it on purpose, because if I want x alone, I'm going to divide by the coefficient, which is negative 1. All right? Newsflash, reminder, if you divide by a negative, Pac-Man turns around. So 6 divided by negative 1 is negative 6. Pac-Man's going to turn around from greater than or equal to less than or equal, and this is now x. And I'm done. Here is my solution. The end, okay? Some people don't like it like that. They like the x to go first. So I gotta turn it back around. I'm gonna write x first, gonna switch this back around to greater than or equal to, and then the negative 6 swings over to this side, and there's my solution, okay? If you wanna push even further, you graph it on a number line, put negative 6 right here, put a circle above it, because there's an equal sign, you shade it in, and then you draw an arrow to the left. Any questions? Hope not. All right. I know I scribbled all over number 3. If you want to copy number 3, that's great. That one is actually for you to practice on your own. Hopefully you can use the skills from number 1 and about to do number 2, so you can do number 3 on your own, all right? So I'm gonna erase all of that, getting rid of all of it. So pause it if you have to, and copy all of that, all right? Are we ready for number 2? Number 2, how many denominators do you see? How many? Ooh, excuse me. How many denominators do you see? 1, 2, 3 denominators, a 3, a 6, and a 9. I want to quickly say that the least common denominator is 9, but if I think about it, 3 goes into 9, 9 obviously goes into 9, but 6 does not. So it's actually 18, all right? And then our procedure is the same again. So I'm going to parentheses, parentheses, parentheses. Got a 9 on top, 9 on top, and 9 on top. All right? Poof! 3 goes into 9 3 times. Now here's something cool that I didn't have to do in the last question. This 3, excuse me, that's just a question number 2. We don't need that in the way. This 3 is going to get multiplied by the entire term. And since the entire term is 3x minus 4, I'm going to distribute. Let me see. So 3 times 3x is 9x. 3 times 4 is 12, so that's minus 12. Okay? This becomes this, nice and clean. Check this out. 6. Oh, what have I done? What have I done? Oh boy. You know what? Normally I would stop the tape and cut this whole thing out, but it's nice to make mistakes. Maybe you can laugh at me a little bit. I just said the least common denominator was 18, and then I'm going to sit here and multiply by 9. That's ridiculous. And I caught myself because I knew that I couldn't poof out the 6 here. 6 doesn't go into 9. See? Embarrassing, but that's how you learn. So I'm going to leave that. I want you to learn. I want you to not be afraid to make mistakes. So let's reset this thing here. 18, 18, 18. So much easier. Poof. 3 goes into 18 6 times, right? 6 times 3 is 18. Now I'm going to distribute that 6. This gives me 18x minus 24. Is that better? Good? All right. Poof. 6 goes into 18 3 times. Distribute the 3. I'm going to get greater than or equal to 6x plus 12. Okay? I distributed the 3. I multiplied. One more time. Poof. 9 goes into 18 twice. Distribute the 2. So there's a plus sign here. 2 times 5x is 10x. 2 times 1 is 2. So I'm going to write minus 2 there. Okay, don't panic. We got time. Now, what do I got to do here? Combine like terms, I think. Let's see. You see any like terms? 6x plus 10x. So let me drop this side down. 18x minus 24 is greater than or equal to 16x plus 12 minus 2 is plus 10. All right? Nice and clean now. Good? You should know what to do from here. I want a variable on one side, not both sides, so I'm going to subtract 16x on both sides. This gives me 2x minus 24 is greater than or equal to 10. Oh boy, now look how easy that is. It's a two-step equation. 2x drops down, greater than or equal to 34. Divide by 2, divide by 2. X is greater than or equal to, quick, get a calculator. I don't know. Let's see. 17, right? The end. And of course, you should probably know how to graph it. So you find 17 on a number line, put a circle above it, shade in the circle, of course, and which way does your arrow go? It is greater, so it goes to the right. Any questions? Type them in the comments. Like, subscribe. Thanks for watching. See ya.